Good morning. I'm Inga Cotton. This is Charter Moms Chats on the San Antonio Charter Moms page. And this summer we are presenting ideas so that you can keep learning at home with your kids this summer, even though a lot of stuff is closed. But if you want to have that feeling of excitement and hope and feel like you're making progress, it's really nice to be learning new things and have that sense of accomplishment of like, I did something cool. And so today we have something I'm really excited. We have Audrey Hagopian, did I say that right? Good.
Yes, you
Okay, and
did.
she is the head of school at Basis Phoenix Primary. So as you know, there's lots of Basis schools in Arizona. There's a handful of them in San Antonio, and there's actually a new campus opening this fall called Basis Northeast. So we'll talk more about Basis towards the end. But so Audrey is a Basis head of school, but she was a Basis science teacher before she became a head of school, and she is a pro at teaching teachers how to make science fun. And so she wrote a guest post for us on our Charter of Summer of Learning page, and that's sachartermoms.com/summer-learning. And so the link is in the description. And if you have your ingredients, I have the list right here. So check out the blog post and gather the ingredients. And I looked at it; it's all stuff we already had in our kitchen. So okay, but let me explain more. So and Audrey has her assistant Savannah. Savannah, can you wave?
No.
So Savannah's going into 5th grade, and she's going to be Audrey's helper to do the experience. So let's see. Okay, so Audrey says she likes reading, cooking, and staying sane in quarantine by hiking and mountain biking. And my family likes hiking a lot too. So, but as in Arizona, as in Texas, you have to be smart to not get overheated, right?
Yes.
Yeah.
Lots of water is necessary.
Yeah, we keep bringing more and more water bottles. Okay, so Audrey, so why is the kitchen a good place to do chemistry?
That's a great question, Inga, and thanks so much for the introduction. We're excited to be here today. I think the kitchen is an excellent place to do chemistry because you'll be surprised about how many materials you have in your kitchen that you can use to do really great science experiments. Things, that your kids would do in the classroom, you can do at home with just stuff that you have lying around, and you don't have to make an extra trip to the store to get the materials. And, after all, cooking is a form of science, it's a form of chemistry. And so you'll be surprised at how many materials you have that will lend well to experiments like the one that we're going to do today. Everything that we're using today I already had in my kitchen.
That's really cool. Yeah, it was great. And like the ingredient list is in the blog post, and there's a cool infographic too that
Yeah.
So it's easy to gather these ingredients up. Okay, so one question before you start the demonstration. What are some tips for families to stay safe at home? So these are all, things you have around the house, but you still want to have good safety.
That's a great question. We're going to be using hydrogen peroxide today, and it's fine if you get it on your skin, but as you know, if you've ever put it on a cut, it does burn a little bit. So I usually suggest that the adult handles the hydrogen peroxide. And then in terms of clothing, I've got a lab coat on. Savannah's wearing a t-shirt that she says it's okay if it gets dirty, but an apron or a baggy old shirt to throw over your clothes just to make sure everyone stays clean during the experiment. But otherwise, everything else is really safe to touch for kids and to handle.
That's awesome. Okay, so that's how we stay safe. Okay, so I'm going to switch to solo view. So you can still hear my voice, but we're going to focus on the experiment and the kitchen. Okay, so take it away, Audrey.
All right, wonderful. Well, thank you so much for joining us today. Today, we're going to do one of my favorite science experiments, which is making elephant toothpaste. If you've got a little one at home, a preschooler or a kindergartner, I love to start this experiment with a story time. Elmer is one of my favorite kids' books that features an elephant. There's also Horton Hears a Who by Dr. Seuss, which I know is a favorite as well. So you can pull out your elephant books to get us started, but this experiment is called elephant toothpaste because we're going to make something in the end that looks like we've made enough toothpaste even for elephant-sized teeth. All right, so we're going to get started. The first item we're using today is hydrogen peroxide, and we need half a cup. So Savannah's going to get a half-cup measuring cup, and because I'm the grown-up, I'm going to be handling the hydrogen peroxide. I'm just going to pour my hydrogen peroxide into my half cup. And while we're doing this, Savannah's going to grab the funnel and put it right into our bottle. If you have a funnel at home, it makes pouring your materials into your bottle easier, but you can certainly just be really careful and pour them in carefully. All right, so she's holding my funnel for me, and I'm going to take my hydrogen peroxide and put it directly into my bottle here. All right, perfect. And then we're going to take our funnel out and put it on our little paper towel on the side. Perfect. All right, now when I'm doing this experiment, I love to add color to it. And Savannah's going to be doing our color for us. So if you have food dye at home, go ahead and grab your food coloring. Again, food coloring is optional, but it makes it fun. And Savannah's going to do a mix for us to give us a minty green color, so it really looks like toothpaste. So we're adding a few drops. It's really up to you. If you want to make it a really strong color, go ahead and add more. Just a few drops if you're running low on food dye, that works too. So we've got some green, and then she's mixing in some yellow too.
Ooh.
Perfect. And then you're going to pick up your bottle, and you're just going to give it a little swirl so that your food coloring mixes into your hydrogen peroxide. Perfect. All right, the next ingredient is dish soap. Just any that you have at home works. And this is a very scientific explanation, a big squirt. You just put it right into your bottle and a big squirt. That's perfect. And then just like the food dye, we're going to pick up our bottle and give it a little swirl. All right, perfect. Okay, now the next step, we're going to make our catalyst. So I'm going to take a bowl here, and I'm going to go get some hot water from the sink. All right, so we've got some nice warm water, and then Savannah's going to pick up our yeast for us. All right, I'm going to show the camera, and then you can cut it open for me. So I've got a packet of yeast here. I know these days yeast can be a little bit hard to find, but I was lucky to find it at my supermarket. I've also heard it's available on Amazon.
Okay, we bought a big pack at the restaurant supply.
Did you?
Yeah, that was ours. We have like a 2-year supply of yeast. So
oh my goodness,
hit me up. Yeah, we're set. Yeah, we make bread all the time. Yeah.
So we're going to take our little bowl here, and we're going to pour just 1 whole packet of yeast. If you're using a jar, it'll be about a tablespoon of yeast. Perfect. And then from our hot water, we're going to do 3 tablespoons of hot water onto our yeast. So Savannah's got a tablespoon measure. And what we're doing right now, we're mixing warm or hot water with yeast, and that's making something called a catalyst. And a catalyst is a material that speeds up a reaction, makes the reaction go really quickly. Perfect. And then we're going to take a spoon. You can just put that over there. And then we're going to mix our yeast and water together. It's a little sticky at first, so just kind of persevere and keep mixing. The goal is to make it look like melted ice cream.
Okay.
So you know you're good when you're at that. And if yours is feeling a little dry, you can always add some more water to it.
Okay.
It's always better to start with less because you can always add more.
Right, right.
All right, I'm going to give it a little stir now too. And then if you want to put our funnel back in our bottle for us. Oh, this is looking good. All right, so this is where the magic happens, or I like to say this is where the science happens. And in this step, it's important we go quickly because a catalyst is something that speeds up a reaction. So it's going to happen very quickly in front of our eyes. Okay.
All right.
All right, here we go. 1, 2, 3. Woo! Oh my goodness.
Whoa! It does look like toothpaste.
It's working really well.
Wow.
So the cool thing about this is, as you can see, we've got a foamy explosion right in front of our eyes.
Exactly.
And the nice thing is it's safe to touch for kids. So I know Savannah likes playing with the foam. We took a chemical hydrogen peroxide, and we did a chemical reaction. So we broke down the hydrogen peroxide, and what we're left with is just water and oxygen gas. So it's safe to touch and play with. So That's our elephant toothpaste.
That is so cool.
Yeah.
It was really exciting to like watch it happen on the screen. It goes.
Yes.
Okay.
And it was a success.
It was a success. Savannah, can you comment? Like, what do you like about the foam? What do you like about making this?
I like that after you're done with it, that you can play with it.
Yeah.
Did you hear that?
Yeah, she said that after the reaction happens, then you get to play with the foam.
Yes.
It looks like it's still coming out of the bottle. Like
it is still actually coming out of the bottle. And one thing that I encourage parents to do at home is have their kids touch the outside of the bottle. And you'll notice that the bottle's really warm, much warmer than even the warm water we put in.
Yeah.
So what this signals to us is reactions can either be exothermic or endothermic. And because when we touch the bottle, we feel heat, that gives us an indication that this is an exothermic reaction, a reaction that releases heat.
Right. Okay, whereas if it were endothermic, then the bottle would feel cold.
Exactly,
afterwards.
yes.
Right, okay. That is so cool. Okay, all right, I'm gonna bring my head back into the screen here a little bit. Okay, and then I wanted to comment on, like, because the blog post is really helpful. Like, part of our purpose with these activities is that we want families to feel inspired, and we want them, like, whenever they pick up a post, that we overcome whatever obstacles they have, right? So like, you did a great job picking an experiment that has stuff you have around the house. So there goes one objection. It's like, you probably already have these materials. And the other thing is that families of different ages can do this, right? So like, so you offer advice for like young children or kids in middle grades like Savannah, or even like for high schoolers or adults, like what they can get out of it. So tell us, like, how, as a parent, how do you guide this activity so that the kids of different ages get the most out of it?
Absolutely, and that's a great question. As I mentioned, for preschoolers, I like to start with a story time, something that, links the story of the experiment to the story that they're reading. And then for little ones, my goal with science is always just getting them excited about science and getting them excited to learn. So it's absolutely fine if they don't understand the chemistry yet, but if they think what they did is really cool and they understand it's a chemical reaction, that's a win there. And then just ask them questions and, what do you see? What do you feel? And get them to explore their world around them. Middle graders can start to understand the science behind this. They can, you can explain that it's an exothermic reaction because they can feel heat. And then for high schoolers, I actually really like this activity for high schoolers because you can get into the science behind it. Which I think is neat. So for teens, what I like to do is I give them the material that we're starting with. So we're starting with hydrogen peroxide, which is the formula is H2O2. Looks like that. And then I try and encourage them to come up with the reaction that occurred. So I say, we no longer have hydrogen peroxide. We know we did a chemical reaction, which means we took one substance and transformed it into other substances. And if you look really closely at the foam, you can see little bubbles in the foam. And that indicates to us the presence of a gas. So we have oxygen gas, and then our foam is essentially water. So this is where we are. And then we have to balance and then I encourage the teens, because they should know this from their chemistry classes, is don't forget to balance your chemical equation. But I won't do that on camera, so we leave a surprise for them to try and work out.
That's right. Right. And the fact that, like, the arrow, it's not just an arrow, but there's a catalyst involved too, right? So the teens can understand that that's an important part of the chemical reaction, that it wouldn't just happen by itself, right?
Absolutely, yes.
Yeah. Cool. Okay. Well, so what are some good variations that you can do on this activity, that just to change it up, right? So like I saw Savannah putting in the different colors of food coloring, so she got to pick what colors. So, but what are some other things you could change up with the elephant toothpaste project?
Well, we like to do all sorts of rainbow elephant toothpaste. So today we went with the traditional minty green, but it's fun to do again and with a different color. So that's a fun variation. Also, if you have some stronger materials at home, you can make it even more powerful where the foam really shoots up. So this is 3% hydrogen peroxide, the standard kind that you find at the store. But if you go to like the Sally Beauty store, you can find hydrogen peroxide in higher strength, and that's really fun to use. It'll make a really strong reaction. You just have to make sure that the adult handles the hydrogen peroxide then.
Yeah,
And
right,
if
right.
you're a chemistry teacher, you can even change out your catalyst. So instead of using yeast, you can use something called potassium iodide, which is a very strong catalyst. And again, will make the reaction much stronger.
Then it might not be kitchen chemistry, it might be like driveway or patio chemistry. That sounds like a challenge. I don't know. Maybe we can track down. Yeah, I think. Well, here in San Antonio, there's a scientific supply store. This is like local San Antonio info, but like there's a place out on Bandera near 604. That's like where all the homeschoolers go to get their science materials. So and the teachers too. So yeah. So that's a little tip for the San Antonio families that there's I'll look up the link and add that to the description. But there's but the purpose here is like these are things that you can do, have a really good, as you can see, a really good reaction just with materials that are you can get around the house and that are safe for kids to handle as well. Yeah. Okay. Well, you mentioned that like especially with young kids, like your number one goal is getting kids excited about science. So so can you like tie that in with like BASIS and like what BASIS is known for? It's known for having a liberal arts curriculum, but also for having really strong STEM, like science, technology, engineering, math education. So so how does this experiment like tie in with sort of the philosophy at BASIS?
That's a great question. And I was lucky enough to start my BASIS career as a 4th and 5th grade science teacher. And my background's actually in chemistry and toxicology. And what really drew me to BASIS was they really value subject expert teachers in the classroom. So people with a degree or content expertise in the subject that they're teaching, so they can really bring that background knowledge from their own career in their subject and bring it to the classroom. And so being a science teacher for me was every day creating my classroom as a world of science and getting kids just really excited about science and being able to be very passionate about just one subject that I was teaching. We also really value teacher autonomy in the classroom. So giving teachers the flexibility to be creative and, make a mess in the classroom and do stuff like elephant toothpaste, because it's going to lead to some really exciting discoveries down the road for students.
Yeah. Yeah. So having teachers who are experts in their subject matter and they can bring that passion and that joy, and then like in the classroom they have the autonomy to like go all in and do these experiments and do projects that get kids involved and get kids excited about learning. So, yeah.
Absolutely. Couldn't say it better myself.
Okay, so I'm gonna if you like what you've been hearing about BASIS and you're curious about it, parents, you can go to enrollbasis.com and you can find out which BASIS charter schools are here in San Antonio. The new one that's opening up is BASIS San Antonio Northeast. And we've written several posts on the blog about like we have an enrollment guide about BASIS. We have school profiles about the medical center and Chavano campuses. I did tours at both campuses last fall and wrote in detail about what it's like. This summer we've had some content describing what remote education has been like at BASIS, and I think later this summer we'll find out more about what back to school will be like at BASIS. So I'm a big fan. My kids go to Grey Hearts, but I'm a big fan of BASIS, and I really want to get the word out so families know that we have this great option in San Antonio. So enrollbasis.com is the site you would go if you want to learn more, if you want to apply for your kids to enroll this fall. So so Audrey, do you have any thoughts of like how to like inspire and motivate families and students to keep learning this summer? Because I really think that this thing, you can only watch so much Netflix and YouTube before you kind of go stir crazy. Like, it's like having projects to do like really makes like, so yesterday we were experimenting with a solar oven, but then it actually rained, so I had to put my potato in the oven to finish baking it. But just the fact that like I was texting with my cousins and they're like, you should put some nails in it, or you.
No, I agree with you. I think there's only so much TV that we can watch before we all start to go stir crazy. So I just encourage families, start with this activity and see how your kids respond to it. And then there are tons of resources available. If you sparked an excitement, then that's great. And continue exploring what you have in your kitchen, what you can mix together and learn together along the way as well. it really is going to break up the monotony of a day at home.
Yeah. And families can have, some good memories. I mean, there's a lot of stress and concern out there, but but you can have good memories of doing things with your kids, and hopefully those are the memories that they'll take with them. It's like, what happens the summer you're home, and remember that time when the green stuff,
crazy thing in the kitchen.
Right.
Yeah.
Okay. Well, wonderful. Thank you so much, Savannah. Thank you, Audrey, for doing. I'm just so impressed, like, to do the experiment live on the live stream. Like, I'm just so impressed. So,
we had to practice. Well, thank you so much for having us, Inga. It was a pleasure to be here, a pleasure to represent BASIS, and to hopefully encourage families to try some science in their kitchen.
Yeah. Have some fun this summer. Keep learning. Yeah. Great. Okay. Thank you so much.
Thank you. Bye.